Hey everybody, in this video lecture we're going to be looking at Unit 6, and in this case we're going to be looking at Chapter 34, and Chapter 34 is Atomic Mass. And so we've addressed a little bit of this in class, but I wanted to make sure that we went over it completely, is that when you have the periodic table, and the periodic table has the box and the element number, and then it has the atomic number somewhere, like maybe here, and then underneath it, it says 12.011. This is the atomic mass, which is an average mass of all the naturally occurring isotopes. Okay, that's what this says. Now, here's the really funny thing about chemistry and that value, is that the average mass is the same whether it's for one atom or whether it's for 6.02 times 10 to the 23rd atoms. Okay? And so that's crazy. And it's just those two values. Okay? This number was specifically designed so that this mass on the periodic table would be the same whether it's for one atom or for that many atoms. Okay? And that many atoms, 6.02 times 10 to the 23rd, that's called a mole. Okay? A mole. A mole is just a quantity. If I told you we had a dozen, you would say that there was 12 of them. If I told you that we had a baker's dozen, you would say that there is 13 of them. So there's certain words that mean quantities. And so in this case, we have 6.02 times 10 to the 23rd atoms. That is equal to a mole. And the reason why this number is scaled up for both one atom and for that many atoms is because it helps us to relate to chemical quantities. An atom is so small that if we had 6.02 times 10 to the 23rd of them, which is, let me write that number out to give you a sense of what it looks like. So there it is, 602 hexillion. That's a huge number of atoms. Now, there's not 602 of anything anywhere except for atoms. Maybe if it's really small, but if you had a mole, if you had 602 hexillion grains of sand, and you put them on the beach, I don't know if anybody's been down to the beach in Jersey, but if you look both ways on the beach, there's sand forever and ever, it seems like. And so when you look forever and ever, is that 602 hexillion grains of sand? Well, I once heard a statistic that said if you took a mole of grains of sand, and that's really, really small, you would cover the whole state of California 10 feet deep in sand. Okay? So that's a lot of sand. But an atom is really small. So if you had a mole of sugar molecules, okay, so if you had 6.02 times 10 to the 23rd hexillion sugar molecules, okay, that's just about a teaspoon of sugar. When you add sugar to your coffee or your tea, or you're looking at somebody doing that, the sugar is, when it's in there, is just about one mole of sugar. So that gives you an idea of how small atoms are. But the point that I'm trying to make is not anything other than this number is good for one atom or one mole. Okay, so this is not only the atomic mass, but it's also the molar mass, the mass of one mole. Okay, and they're interchangeable. And so the reason why we do this is because we want to be able to relate to the quantities of materials that we're using. Chemists can't manipulate one atom at a time, or very few chemists can. And so what we want to do is we want to use a quantity that we can understand. We can't understand that one atom of sugar or that one molecule of sugar, but we can understand a teaspoonful of sugar, and we can do stuff with that teaspoon of sugar, and that then would be the using this. So, atomic mass and molar mass are the same number, they're just different units. Okay, so that's the last thing that I want to talk about. Atomic mass, if we're talking about the mass of an atom, that's an A at, let me get rid of this stuff here. Okay, atomic mass has a mass of AMU. It stands for atomic mass unit. Okay, and so that's the amount of mass that one atom has. It's all the protons and neutrons, and then it's the average of all those isotopes. The molar mass is the mass of 1 mole, and when you have the mass of 1 mole, that's going to be in grams per mole. So we always have 1 mole, that's the whole point. So it's in grams, okay? So the grams per 1 mole. So that's the difference, okay? It's the only difference is the unit. And we all know that units are important too when dealing with chemistry. So, so that hopefully clarifies how different atomic and molar mass are, but also how similar and how they're the same. So have a great day and stay out of trouble.